Okay. Okay. We will start from the beginning. It's about how to map from rational or relational database from ER diagram to relational database schema. So we need to get relational database schema from ER diagram. This is a mapping. Actually, we have 7 steps. First, we will map the regular entity type. We will look to our ER diagram, find the regular or the normal or the strong entity types and mapping it. Then step 2, mapping the weak entity types. Then we will start to map the relationship. We have 3 types of relationship here: one-to-one, one-to-many, and many-to-many relationship. And each type of this relationship have different rules to how to map it. We will see it by examples also. Then multi-valued attributes. And last step, if we have more than the regular relationship or the binary relationship, if we have ternary relationship or 4 array or 5th array relationship, we will see this. I think it's difficult to have more than ternary array relationship type. Okay, first step, mapping of regular entity. We mean about regular entity, any entity except the weak entity, any entity type except the weak entity. So in this ER diagram, we have employee, department, project, 3 regular entity type and 1 weak entity type, which is dependent. So we already have this from last week. We will start from the beginning. It's better. Okay, then we have department. We will make a relation R for the entity department, and inside it we will put all the normal attributes. Multi-valued attribute have a different way for mapping, so we will not put currently the multi-valued attribute. Okay, in this step we have the entity and the attribute inside the entity. We will put it like this: department name, department number. This later we will speak about it. Okay, and we have another entity here, which is entity type, which is employee, and inside it we have social security number, birth date, name. You look to the name, it's a composite attribute. It's actually consists of first name, middle name, and last name. So if you have composite attribute, just convert it to simple attribute by taking the parts of this attribute. So we have SSN, we have birth date, then we separate the composite attribute into simple attribute: first name, mid name, last name. We have address. I will not put everything here because similar. Okay, address, because the space. But if you have question or you have your database, you want to make mapping, you have to do it. Address, salary, and 6, you can continue here. Okay. We have also projects. We have also project. So I will.
Doctor.
Yes.
That means the multi-valued attribute.
Sorry?
When we mapping it, we'll deal with it like every value in the multi-value attribute like a new attribute. يعني,
Yes, the
here,
composite. You mean the composite
yes,
attribute.
the
Composite
yes.
attribute, you separate it into single attributes like this. Okay, its name consists of first name, then you use it. First name, middle name, last name. Okay, no need to put the name itself because it's consists from parts. So you take the parts, the simple attributes. This is the mapping for it.
Okay, so but we'll have a topic like reverse the operation from schema to ER diagram. If we reverse the operation,
You don't need it.
okay.
Okay, look. To be clear, we speak. Let me use a whiteboard here. Oh, why whiteboard take long time? Okay. 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 Consider you are a database engineer and you have description for the database come from the software engineer after doing some meetings with the customers. Then you will have description for the database. So you need to build your database. So you start from the description that come from the user. Of course, you are not software engineer, you will not meet the user. Then you have the software engineer in the middle here, who will make meeting with the users, end user to get the requirement. Part from the requirement will be the description for the database.
Okay.
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 Then the final step here will be the database itself, which will be part from the application. But we speak here, you are not application developer. You are database engineers that you will take this description to get the database. Then here, the main part that we speak in this course, how to get the database from this database description. We speak here about database that have integrity and do not have redundancy or any problem with that famous in the database. So to get correct database, you have steps. Okay.
Okay.
First step, after you have this description, you need to convert this description to ER diagram. Okay. Then
Okay.
after you get this ER diagram, you need to get the relational schema. Let me just write it like this. We already speak about ER diagram. Today we speak about how to convert this ER diagram to relational model, relational schema. Last lecture, we get some information about what's the meaning of relational model and relational schema, what's the relation, what's the component of the relation, and what constraint you have to take in consideration when you convert to relational schema. Next step here, you need to make some operation, some normalization, okay, to your relational schema to take into consideration the data integrity and to remove redundancy. So after that, we will speak about normalization and some operations that you have to make on this relational model. After finish this, you can convert this relational model into database using data definition language. Also, you need to know the data manipulation language to make operation inside your database application. We will cover all these issues. So currently we are speaking about mapping. Is it clear now?
Okay, thank you.
So
Clear now.
it's the steps going from here to here, not the opposite.
Okay.
You don't need to convert from relational model to ER diagram. Actually, ER diagram give you overview about the database and make it simple for you to take view for this database and to discuss with the end user or with the software engineer to get the best picture of this database. Then you start to convert it. And why relational model? Because you can use the relational theory and set operation to use this relations. You have the relation, it's a set of tuples, yes? Then you can make union, you can make intersection, you can make subset from the data. So to get benefit from this relational algebra and relational calculus using this data manipulation language. So even here after this one, we will speak about relational algebra and relational calculus. Then when we speak about SQL in data definition language and data manipulation language, we will see how to apply this relational algebra and calculus using SQL. So after this one, we will speak about here about relational algebra and relational calculus, and later we will see how to use SQL language to actually using this relational algebra and relational calculus. Okay, hopefully it's clear now.
Very clear, Doctor. Thank you for your explanation. Thank you.
Okay. So he was here, yes. Okay, then project. We convert this entity type into relation. Then we take all the attributes here. We have project name. We have project number. And we have location. Here you can see location for the project, simple attribute, normal attribute, not like department, because department can be in more than one location. So it multi-value here, multi-valued attribute here. But here location, it's a simple attribute, so we can take it here. Okay. Now we need to take one of the keys here as a primary key. So we have project name, it's unique, so it's a key. And we have project number, it's also unique, and it's a key. We can take anyone. We prefer usually to use numbers because it take less time for processing and take less less storage. Okay, so it's faster to take as a primary keys the numbers. That's why I will choose the primary or the P number here, project number. I will choose it as primary key. Okay, now we have all the normal entity type or strong entity type. We convert them into relations. What then? For each regular or strong entity, you create a relation. Then you choose one of the keys as a primary key. This is the first step for mapping. Second step for mapping, it's the mapping of weak entity type. For weak entity type, you need to create relation also and include all the simple attribute of this weak entity type. So what's the difference between the weak entity type and the normal? The difference will be in the primary key. The primary key for this weak entity, the primary key for the weak entity will consist from two parts. First part will be the primary key of the owner entity plus here combination of primary key of the owner, this first part, plus the partial key of the weak entity. And it's no need for us to return and speak about partial key. We said that the partial key, it's attribute of the weak entity that can identify the weak entity if combined with the owner or strong entity. Alone, without a strong entity, it cannot identify the weak entity. Example, the name. I give this example always. If we have the dependent here as a weak entity, maybe we can have two employees have the same dependent. For example, employee X and employee Y have a son with the name Ahmed. Okay, then it's not uniquely identify this weak entity. But if you connect it with the employee, when you said employee X, he cannot have two dependent with the same name. So the name of the dependent with the owner entity or the strong entity here, combining between them, we will get the primary key. It will uniquely identify this weak entity. So for the weak entity, we will create relation. Okay, we have weak entity here, dependent. And the attribute for this weak entity will be, I will start from here, I will tell you later why, will be the dependent name, then the sex of the dependent, birth date, and relationship. Okay, we have D name as partial key. What is the primary key for this weak entity? It will be the partial key plus the primary key of the owner entity. What's the owner entity here? Employee. What's the primary key? Social security number. So we will take copy from this social security number in the weak entity here. Then we have employee social security number. What's the primary key here? This 2. Then the primary key, not one attribute for this weak entity, 2 attributes, the employee social security number and dependent name. When you take copy from primary key in another relation, it becomes foreign key for this relation. So the primary key of employee as a copy here become foreign key. Why foreign key? Because it come originally from employee. It's not originally from dependent. So foreign key usually point to or have to point to primary key. So I will just make a copy here. So we have here SSN as foreign key have to point to the primary key. It's difficult actually to use because it's not supported here. You can use Microsoft Word, you can use any editor to do this. Or even I can do like this. Okay. Where's the property? Line. Okay. Okay. Then foreign key, FK, have to point to primary key. We finish from next or second step. Third step, mapping of one-to-one relationship. Okay, if you have one-to-one relation type, you have three choices to map it. If you look here, we have this one-to-one relationship manage between employee and department. This one-to-one relationship, you have three choices. First choice, to have the primary key from the partial. I need you to remember back to retrieve the ER diagram concepts. We speak about the total and partial participation. The side with the partial participation, we make it single line. Total participation, we make it double line. Total participation, this means all entity here will participate in the relationship. Partial participation means that not every entity here participate in this relationship. For example, manage. Not all employee manage department, but all department should have manager. That's why department have full participation or total participation, but employee have partial participation. Single line for partial participation, double line for full participation. So you need to take the primary key from when you have relation one-to-one. You will take the primary key from the partial participation as foreign key in the total participation side. This first choice. So if we take the first choice, we will do like this. We will take SSN for this employee as foreign key in the department. But to identify it, we will name it from manage or manager SSN. So MSSN here or SSN, it's the employee primary key that here we take it as a foreign key. So foreign key, F key, have to point to its primary key. So we have pointer here from MSN. Sorry, it should be like this. You just put underline for the primary key. So this foreign key point to its original primary key. Okay, this one choice. What other choices that we have? The other choice that you have, it's to merge the relation. This means you will put the two sides into one relation. This appropriate only when both sides participate are total. And if you don't have any other relationship between these two entities. So in our case here, we cannot merge between department and employee in one relation. Why? Because here it's not total participation. And also we have another relationship between department and employee. If we don't have relationship between department and employee and the participation full for the two sides, then we can merge this two relation or two entities entity type into one relation. This is the other choice. Then if you have relationship one-to-one, and the two parts of the relation full participation and they don't have another relationship, then you can merge between the two entities of this relation into one relation. Okay, now what about, I will speak about this start date. Okay, after we see the third option. Third option, that you need to create a new relation for this relationship. This means I come like this, right? Okay, we have manage. Okay, we create a new relation for this manage. Please turn off your mic. So you create this, the third choice. You create a new relation. I will not take this choice now, but to show you, you will create a new relation like this and name it manage, for example. Then you take here the primary key of the two sides, which is department number and social security number of the manager. Okay, and any extra attribute for this relation. For example, here start date. Okay, what's the primary key for this relation? Will be both the primary key of the both side, department and employee. This two will be the primary key. Of course, if you did like this, you don't need to take this one as a foreign key. Now the relation between department and employee who manage the department will not be directly, will be through this one. This will point here and just I will remove it just to show you, and this one will point here. Okay, this primary key become foreign key here. This primary key become foreign key here, and both foreign key will create the new primary key for managed relation. This is the third choice. We take this choice. Okay. We take this choice that we will take the primary key from the partial participant as foreign key here in the total participant. Now, this attribute of the relation, we will take it inside the full participant, like a foreign key. Okay, you will take any attribute in this relationship into the full participant or the total participant part. Then it will be added here. We can call it manager start date or start date. So you have three choices. Here you have two choices only. The third choice not applicable, which is merged between these two parts, employee and department. Here not applicable. Why? Because you have here partial participation and you also have another relationship. Okay, so we can, in our case, we can use this choice and we can use this choice, the cross-reference. This means create a new relation for this relationship. Okay, and take the primary key of the both side as a foreign key inside this relation, and the combination between these two foreign key will be the primary key for this new relation. Okay, this choice, for our example, we cannot take it because we have this criteria that we should have both side or both participants should be total and should not have another relationship. Okay. If we have one-to-many relationship, it's very simple. You just take the primary key from the one side as a foreign key to the inside. So if you have one-to-many relationship, you will take from the side of one into many. This will be the primary key will be taken from inside as a foreign key for from one side into inside. Okay, it's simple now. We have one-to-many. We have one-to-many relationship, and we have one-to-many. Okay, even if this one recursion relationship, it's still one-to-many. Okay, then we will take one by one. We have this one works for how to map it. We will take the primary key from the one side as a foreign key for the many side. What primary key here in the department? It's department number. So we will take department number as a foreign key here for the employee. So we have the number as a foreign key here. I will copy this one because this type of connector. Okay. So we have department number inside employee as a foreign key, and its original primary key will be department number. Also, we have department and project. We will take department number from department into the project here. So we have also the number as a foreign key inside this department. It's difficult to get it. Okay, you can make it like this. Drawing for this will be this one also same. Okay. What else? We have this one, we already make it for the weak entity.
Doctor, you link it to project location, not the number.
Sorry? Okay, okay, okay. Thank you. Okay, thank you. Here, supervision. We will take the SSN number of the supervisor as a foreign key here. So in the employee, we have super. Let me name it super like this, not the total name. SSN. It's a foreign key. What's the original primary key? It's the employee SSN here. So you can take foreigner key inside the relation itself of the primary key if you have recursion like this. So we have I will make it from here. Actually, I tried to find applications that could draw this one. I could not find applications, so we can use here eDraw Max. We can use Word. Maybe Word much easier, but it will not help me here in this class. So here foreigner key FK pointed to SSN as a primary key. This means we have, for example, employee X have a supervisor employee Y. So X and Y employee, and they have SSN. Okay, that's why we called it recursion. So this recursion relationship, one to many, it will be mapping like this. Is there still any other one to many? No. Then we continue here. For mapping of many to many relationship, we have only one choice: to create a new relation for this relationship. Okay, then for this relationship between two entities, we will create a new relation. And what's the content of this relation? What's the content of this relation? For example, we name it as, the content of it will be the primary key of the both participant entities as a foreign key here, and both primary key from the both side participant will be the new primary key for this entity or this relation, and any other simple attributes of this relationship. We will see this in this example. Many to many works on this many to many relationship. We will create a new relation for it. a new relation. Okay, what's the name of this relation or table? We already spoke last time that informally we can call it a table. We have table dependent, we have table project, we have table employee, but formally we name it relation. Is there a problem here? Oh, there was a student asking to join this meeting. Okay. So we name it relation. It's different than relationship. We speak here this relationship. This relation means table. Informally, you can name it table. Okay, this works on. What's the content of it? This relation have this content, have the primary key of the participant of the relation. Then we have primary key of the project. Where's the project? We have P number. Okay. And the primary key of the other side here, which is employee SSN. And any item that or attribute of this relation. We have here hours for this relation works on. So we take it. Okay, this foreign key will point it to the project. I will copy it and paste it. So we have I prefer here. Okay, we continue. I think it will be better next example to use directly maybe Acrobat, the Acrobat, and just draw using the pen. It's much faster. Okay, then ESSN here, foreign key, it's originally primary key, employee SSN, and project number, it's this one. Actually, it's not underlined. Okay, and we have project number, will point it to project number. Maybe we can just make a group and copy and paste. Okay, what happened here? Oh, anyway, I can just draw it again. This foreign key, primary key, and blah. Sorry, I take time using drawing this. Okay. Okay, what about the primary key for this one, for works on? The primary key will be combination between the two foreign key, ESSN and the project number. This both will make the primary key for this new entity. So the primary key, we underline the primary key. So part from primary key could be foreign key like this, ESSN and its original SSN project number. Like also independent, we have ESSN, part from the primary key, it's foreign key for SSN. Next step, it's simple for many to many. You just create a new relation, take both side primary key as a foreign key in the new relation, and make the both key here as the primary key for the new relation. Multi-valued attribute. Multi-valued attribute will be converted to relation or table. So multi-valued attribute, you need to create a new relation or a new table for multi-valued attribute. And the content for this multi-valued attribute will be the primary key for its parent, okay, entity as a foreign key. And what about the primary key for the new relation? Will be combination between the attribute itself and the key of the owner entity. So here we have multi-valued attribute, which is location. We will create a new relation for it. I think we need only two. I will put it here. Okay, what's the name of this? It's location, so I will name it location, but location of what? Location of department, so I will name it deep location, for example. So what's the content of this relation will be the attribute itself, which is location, plus the primary key of the owner entity, which is department, and its primary key D number. D number. Sorry. D number. Okay, then D number is this foreign key here, and its primary key will be this D number. So it's foreign key. Okay. What's the primary key for the new relation or the new table department location? The primary key will be the multi-valued attribute plus the foreign key. Actually, if you remember, last time we take example about non-atomic value and atomic value. Last lecture. Okay. There was an example here. Let me show you. Let me show you that example. It was last lecture when we spoke about the characteristic of the relation. Okay, we mentioned that the values should be atomic. Yes. And we give this example, second example. You see here color, it's multi-valued attribute. When we put it here like this, then it's a problem with relation characteristic. So you need to divide this into two columns. This problem happened because mapping was not correct. If you have mapping like this, correct mapping, you will not have multi-valued attribute in the same relation or in the same table. So you will not have this problem, non-atomic value problem. Okay. That's why you need to follow the mapping algorithm or the mapping procedure, so you will not have any problem with your mapping. Okay, we will finish soon without a break. Then we can finish our lecture early. Okay. Now we finished our example here. We already converted everything. We have everything here. We have all the relation. You look, we have works for, okay. We finish it, control and everything. We have all the attributes here. It's okay. Maybe employee, we can continue, but we don't have space here. You have to continue the address, salary, and 6 attribute. This simple attribute, just add them here. So this, let me make it full screen, maybe. Okay, this is the final result. Of course, you can organize this better. Maybe you can put works on here, depend the project, you can put it here. Okay, so you don't have many crossing between pointers. You can just reorganize here the drawing to make it much readable. Okay. Okay. Then what else we have? Sometimes you have a relationship more than 2. If you have n more than 2, for example 3, it's difficult actually to have more than 3, but it's sometimes you have 3 or ternary relationship type. Maybe you have 4-array relationship type, but it's difficult to have more. What I should do here? If you have, for example, ternary relationship, you will create a new relation, and inside it you will put a primary key for the first relation. For example, if you have relationship like this, its name XY, for example, and you have entity, for example, 1 and entity 2. We will take example also, entity 3. Then you need to create a new relation for this one, or a table for this one, XY, for example, and take the primary key for all the sides, big key 1 and big key 2 and primary key of the third entity, and any extra attributes that here on this relationship. For example, attribute A1 you have, then you will put A1 also. The primary key for the new table or the new relation will be all this one, and each one, of course, foreign key for its original. This will point to a primary key of E3. This will point to primary key of E2, and so on. Okay, then you need to create a new table or a new relation. For example, we will name it as a foreign key. You will include the primary key of all the relations that participate in, or all entities that participate in this relationship, like we did here. Also, you will include any simple attribute of the relationship itself. And the primary key of the new relation will be from 3 parts if you speak about ternary, or 4 if you speak about 4-array relationship. All combination of all this will be the new primary key. Here example, we have supply relationship, we have project number, we have supply and its a primary key supply number, we have part and its a primary key part number. So we have 3 relations here: project and its a primary key project number or project name. Maybe you have others attributes, and also you have here supplier, and we have as name as a primary key. Part also will convert into table or boxes, and it have primary key part number.
Sorry, doctor.
Yes.
Why we
Okay.
consider project name is a primary key? Maybe it's repeated in other projects or anything.
It's depend on the collected data. So if the end user said we have for each project unique project name, then you can take it as a primary key. Okay.
Okay.
So
Okay,
it's
doctor.
not
Thank you.
depend on me as a database engineer. It depends on the requirement.
Okay, doctor.
If some companies said, okay, we can have repeated names for the project, then you cannot take it as a primary key. Maybe you have a project number or something like this. Actually, for me, I prefer to have numbers because it's faster for database. Using numbers in the query take less time than using names, because name take more space in the memory and will take more times. So it's depend. Here for me, I will show you this example, our example. Here in our example, for a project, we have two unique, name and number, project name and project number. I choose here project number, but if you choose project name, also it's correct. Maybe you will not choose project number as a primary key. Then you can take one of the keys as a primary key. It's depend
Okay,
on
doctor.
two things. The data, collected data from the user or collected requirement. He mentioned that the end user mentioned that project name unique and project number will be unique. Then I can use project name or project number. For me, I choose here project number. In this example from the book, okay, he chose project name as a primary key. It's if it's unique, then you can choose it as a primary key. Anyway, to convert this type of relationship, each side will be each entity, this normal entity or strong entity. So each entity will take it as a relation. Then the ternary relationship here will be converted also into a table or relation. I will call it supply. What's the content of this relation? It's the primary key of all the participants. Then I will take project number, project name here, and part number and S name or supplier name. Then we have three content here: project name, supplier name, and part number. Okay, everyone is a foreign key and it should point to its original primary key. And the combination of all this foreign number will be all as a primary key for the new relation or for the new table. So supply, what's the primary key for supply? It will be project number plus supplier number plus part number. Now, also, if you have any simple attribute in this relation, like a quantity, it will be added to the table or to the relation. So it's like this, working like this. If you have 4, 5, anything, same things. If you have, for example, XY entity and its primary key X, you will take it, but also here. Okay, 5, 6, any type of n array relationship working like this. So this is the answer or the mapping for an array type relationship. Okay, if you look here, it's the answer for our example, the result of the mapping. You will see it same like what I wrote before. Here, he take project number, yes. Okay, we have another example. We tried to make mapping for it very fast. I will take it. Maybe it's better to. I will. Okay. New. Oh, where is it? Not this one. This one. I just want to take it. No, it's better to you like this. Okay. Okay, we have this example. Then we will follow the steps. First step, we will take any normal entity. For example, we have here sea, ocean, lake. I will keep it open if we need more. So we have this one, sea, ocean. It's enough because the time, we don't have enough time. Okay, what's the content? We have name. It's difficult here also to draw. Have name. Use this one, it's better. Okay, what else? We have state, country, also normal. So we have state. Okay. We have name also and content, I think. So I will copy this one. We have name, we have content. Continent. Yeah. Okay. So I will not continue everything. Just I will have the primary key for other parts. This one, ship type. Ship type. Ship type, I will take just the type. I will not take the other attribute just for the time. Okay, what else? We have here ship. Also, it's normal entity type, so it will be converted to relation. Okay, let me write it first. Ship. Okay. Ship also have S name. S name. Okay, what else? We have here, we finished the first step. All the normal entity, we converted it here. This one weak entity, this one weak entity, this one weak entity. Okay, this is good example actually. You see here, I have question here. I want to see if you have understand it and you have the critical thinking here, or for this weak entity, what is the parent? Port.
The parent is
State country.
Ship.
No, it could not be cheap. You know why? Because this participation, you see,
1-to-1.
it's partial participation. And this one partial participation could not be. Then who will be the parent entity? It will be both these two, not one parent.
Why both of them?
Because both of them full participation. Here, full participation, full participation. Then this one alone cannot identify this one. It's from you have to understand your example. Here I said port. You know the port, yes?
Yes.
Okay, state or country could have many ports. Yes or not?
Yes.
Sea or ocean or lake could have many more than one port. That's why both the state, okay, and the sea will identify the port with the name of the port. You will not have the same name of the port inside the same country and on the same sea or ocean. That's why both will be the parent. It's simple just to understand that the full participation will be the parent. You can have more than one parent for one weak entity. Okay, we finish all the type of the entity. Now when we start for the weak entity, each weak entity will take, because I have a meeting after this, I have only 5 minutes remain. So I will quickly just describe what's the result, and maybe you can give me, I will make it as a homework after finish this description here. Then as weak entity here, board, it will convert it to relation like this, and the content of it will be the partial key. Hopefully it will read right here. B name and the primary key of the owner, which is the name of the C. Okay, I will make it C name and state name, and this one C name. This come from this part, this one come from this part. So all will be the primary key. The original for this one, it's a foreign key for state. And this one foreign key for this one. Okay. This one, if you look to this one, it's difficult actually to convert it. You can take like this. Visit, start date, end date, visit. Actually, this one, it's come from the relationship itself. Start date, end date, and you will take as name and the primary key. Oh, it's complicated here. Okay, this visit, ship, port, you will take the ship name and you will take the primary key of all this one. port name, state name, and C name, because you will take the primary key of this one here and the primary key of this one here, and all this one will be here. Because this week, it's actually coming from the relationship itself. It's difficult because it's ternary. So the solution will be, I will write it on the Word here, this one, as a table.
Doctor,
will
just
have.
please don't give us a question like that
Okay,
in
okay,
exam.
but the
So
solution,
hard.
you have to understand the example to understand the solution. It will take the primary key from all parts. S name from the ship. The primary key of this one, it's not only the B name. It will be the B name and the state name and the C name, yes? So you will take this entity here, the primary key of this entity. So it will have B name. Actually, I did not put this complicated example here in the slide. This slide comes from the book itself, the author of the book, okay? But it's good to understand it. Of course, if I will put the question in exam, I will not put complicated like this one. State name and C name. From where comes this three? B name, state name, C name. It's come from port, because port primary key is all these three components or three attributes. This one come from ship here. And from this one, actually this one, when you see like this, ternary relationship, and you have this one weak, the parent actually itself, it's come from the visit. You will see the name itself, visit. You can merge it here, actually. You can merge this one weak entity here. So it's the mapping for this one itself. Start date. You know why they put it alone? Because start date, it's a partial key. So it's come from this idea. I will describe the idea for you. Where to draw? Let me draw here. I tried to delete this part and show you what the problem here. If I know it's complicated, I will not waste your time here, but you need to understand it. Actually, it comes from the idea like this. Visit this one. You look, it's one-to-one relationship. Usually one-to-one relationship you can merge, okay? So it's come from this idea. We don't have this one. We have a start date and we have end date. So this one, many-to-many relationship. You can see here the star, maximum star, this means maximum money, okay? Many-to-many relationship. So to convert this relationship, you create many-to-many relationship, you create a new relation or a new table and take the primary key from this side and the primary key from this side. Yes? Then why he separate this one here? He separates this one because he needs this as a partial key. So if he merge here, you cannot make start date as a partial key. So the owner of this weak entity actually is the relationship itself. And it's separated only because we need the partial key. Then what's the benefit here? The benefit here, when you want to make the primary key here, you will take the partial key with the owner primary key. So the primary key for this relation, which is visit, this is a visit relation, the primary key will, the primary key of the owner, which is S name, B name, set name, C name, with the partial key, which is the start date. All this will be the primary key. So it's originally it's a many-to-many relationship. That's why I told you you need to understand it. It's originally, before get this as a weak entity, it's originally like this, just visit this ship, visit this port, and ship can visit many port can have many ship visited it, so it's many-to-many relationship. And it's have the starting date for the visit and the end date of the visit. Why we separate it like this? Originally, there is no entity. It was like this. Because we want the start date to be as a partial key, that's why we separate it as a weak entity. Yes, go ahead. What you want to ask?
Doctor, about the relationship between port and state and C.
Port, sorry, port, let me
Port,
focus.
state, and C.
Port and state is different relation. Port
No,
and C.
can we consider it here as a theory relationship and make the word here belong? So this port belong to state and belong to the C. It will be theory relationship.
Yes, here you can make it, I think, because if you merge it, it will have the same
And it will be
idea.
easier
Why?
for
Because
us.
this one, no, you cannot merge. Why? Because if you merge it, then you need here for this one a new relation or a new table. This is a different. Now I understand your question. Your question is a question, my friends. Instead of having like this, we have one relation between state, C, and board. Your question like this, yes?
Yeah, doctor.
In this way, this one will be converted into table or relation. It's different. Okay, you understand why not?
Yeah, I understand this.
You cannot do this. Okay.
Okay, doctor, I get it.
My question here for all of you. You understand what about visit? You understand it original? So one of you will ask me, so how to understand this? actually you will understand it if you are the database engineer for this project. Why? Because you will be the one that he draws this one and understands that what's the origin of this one. But if I give you like this and you did not understand it come from where, it's difficult to convert it. So if I put a question in the exam, I will not put something like this to confuse you. But because here I understand what it happened, so I can convert it. I converted it. Why? Because I understand this one as a weak entity. Actually, it's originally the visit relationship itself. But we separate it because we need a partial key. This is the only, maybe it's not very common. That's why you will not find it as apart from the algorithm. Okay? Hopefully you understand from where this comes and how to convert it. I convert it as I convert any many to many relationship. I create a new relation. I take the primary key from each participant and the partial key here. So after finish this, you don't need to convert this one. I already made this one here inside the relationship itself. Okay?
Okay, doctor, but in the AI diagram, the relation, it is not many to many.
No, it's many
It's
to
one.
many. You look here.
Star.
Star means many. You speak about the maximum, not the minimum. The minimum, it's the cardinality, it's the participation, and the maximum is the cardinality ratio. The maximum here stars this mean many, and here stars this mean many. This one, the minimum and the maximum one, this mean it's originally come from here. When we speak about one-to-one relationship, if you remember, we said you can merge. So it's originally this visit, it's originally the relationship itself. So you can cancel it and put the item directly here. Then you can understand how to map it.
Okay.
Okay, then
The topic today.
it's actually mapping for many to many relationship, not ternary. Just merge this weak entity with its original and keep this partial key because you need this partial key as part from the primary key. I want to make it bigger. So I underline the start date, C name, state name, and B name, and S name. S name come from chip, B name, state name, and C name come from board. Okay. And for me, if I want to ask you, if you are database engineer, what you will do for board? For me, instead of put B name and state name and C name like this, I will put serial number as port number. Port number, not in this example. I mentioned this best practice as a database engineer. You will put number, number, And then you don't need, CNAME, and so I converted it to normal entity and put the B number for it. If I'm building database, actually, because I think it will be much easier and straightforward. Okay, any question here? I will give you more simple example as a homework, not this one.
Yes,
Okay.
doctor, we want more simple because it's complicated.
Okay, I will give you more simple homework. Maybe I will send it today. It's actually good to have like this example to get many ideas here to see how to think in each part. Here, weak entity, we see that this weak entity have two parents. Here, this weak entity, we see that this weak entity, actually its origin come from the entity relationship itself. So we can return it here. This weak entity, it's normal. You have timestamp as a partial. Just one thing, when you convert this one, okay, here ship as a owner, we will take its a primary key here in the weak entity, yes? So in this weak entity, ship movement, we will take as a foreign key as name from ship here, as name, and we will take timestamp. Timestamp, as you can see, composite attribute. So you will not take timestamp itself. You will take simple objects, simple attributes, date,
On time.
okay, the writing here difficult. I will write, then I will draw. Date and time. Actually, date and time, it's a partial key because this timestamp consists of date and time. And you have longitude, okay? Then what's the primary key here? Who will answer? What's the primary key for ship movement? You remember the weak entity primary key will be the primary key of the parent or the owner, which is ship, plus the foreign, the partial key. Then the primary key for ship movement will be
As name.
as name plus what?
Date
Plus
and time.
timestamp, which
Date
is
and time.
date
Date and time.
and time. So the primary key will be as name, date and time. And of course, this as name, it's a primary key, and at the same time, it's foreign key to its primary key origin. You can point here. If we have ship, we don't have ship. Okay. For this relationship, you will take a primary key from the one to the many as a foreign key here. Then ship will have as name owner and will have type as a foreign key. You understand one to many. One to many simple. It's the most simple. You take the primary key from the one side as a foreign key in the many side. Okay, that's all. today or tomorrow, I will send you a file for the homework, second homework. It's about mapping, okay? But I will find or I will make much simple homework, not like this one. That's all for today. We already take 2 hours. I just have 9 minutes for rest, and
Thank you,
I
Doctor.
have a meeting.
Doctor, the solution for the first homework.
Okay, I will send you the solution. Okay.
Okay. Okay.
Okay,
good.
Doctor.
Okay, thank you, Doctor.
Okay. See you
Thank you.
inshallah next
See
week.
you.
That's
See you,
all
Doctor.
See you,
for
Doctor. See you.
See you,
for
Doctor.
today.
Thank you, Doctor.
Thank you for attending the class, and
Welcome.
Assalamu alaikum. Guru
عليكم
Shunus.
السلام.
وعليكم السلام.
عليكم السلام.
عليكم السلام.